Hello, this is Mr. Hanson. I wanted to look at absolute value functions with you today. So this first function says y equals the absolute value of x. This is the parent function, and we can relate all other absolute values to this absolute value function. If we put in a number for x such as 1, y would be 1. If we put in 2, y would be 2. If we put in 0, y would be 0. If we put in negative 1, the absolute value makes that a positive because we're measuring distance from 0. And if we put in negative 2, it would be at 2. So what we end up having is this V shape that goes something like this. All right, let's take a look at just some variations on this. What if we had absolute value, y equals absolute value of x plus 2? We're saying take any of these values that would equal to y, and add 2 up to them. So you're just going up 2, and it would look something like this. Just kind of highlight that in red, like that. Okay, another thought. Let's do this one in pink. Y equals negative 1 times the absolute value of x. So now everything that was positive, which is everything in absolute values, becomes negative. So it would look more like this. Something like that. And let's do one more. Let's go y equals 2 times absolute value of x. So we're doubling if we had, and I don't know, let's do this one in green. Instead of 1, 1, we're going to have 2, 1. Instead of negative 1, 1, we'll have negative 2, 1. So it's like you've got a slope of 2, so it's going to go up a little bit steeper like this. And you can kind of think of combinations of all these different things. Let's look at one more with an actual word problem. This is if you had a bunch of jelly beans in a jar and you wanted to guess how many jelly beans there were, and let's say x is the number of actual jelly beans in the jar. Well, x is your guess, and y is how much you're off by. So if you guessed 210, plug in 210 there, you're off by 0. If you guessed 211, you're off by 1. If you guessed 209, you're off by 1 as well. So x minus 210, we're going to the right 210, like that, and that's my my graph for that particular function there. Let's just kind of finish this off with y equals a times x minus h plus k. So h and k are your vertex. And a is like your stretch. And also if it's at negative a, you're going to go upside down like that. You're going to reflect it over the x-axis. This might look really familiar to you. I hope it does, because in quadratic functions we said y equals a times x minus h squared plus k. Same kind of structure in that. And so yeah, there's a comparison here. Recently we've worked on square roots. So if you had a times the square root of x minus h plus k, that's h and k again would be the vertex in your equation, and a would be the measure of stretch there. So I hope this helps you with being able to take a look at a parent function like this, and then compare it to what you've got, and be able to transform that function anywhere on the graph, reflect it over the x-axis, and make it wider or narrower, do all of those things. Let's practice just one and we'll call it good. Y equals 2 times x minus 3 plus 1. So First of all, the vertex is at 3, 1. Right there, 3, 1. If I plug in the point 3 right here, 3 times minus 3 is 0, and 0 times 2 is 0, and plus 1 is 1, so 3, 1. Okay, let's do this. Let's take a look at the number 2. That means that we're going to go up 2 over 1, or up 2 back 1. And you have a function that looks something like that. So hopefully this makes some sense to you. I'm going to close this video. This is just a quick, easy video on graphing absolute value functions. Thank you for listening in. This is Mr. Hansen signing out.